Uh, there's a number that I want to write up on the screen here. And what this number represents, and this is a scientific notation, this number represents all the atoms in the known universe. And so you can see that this is a very efficient way of writing a very large number. Shorthand method, scientific notation, represents all the atoms in the known universe. Okay, and there's another number of interest, and it's 10 to the 30th. And what 10 to the 30th represents, again, in scientific notation, it's a large number in shorthand form, which represents the number of seconds since the supposed Big Bang. Now, if you believe in the Big Bang, personally I don't. I think it defies all the laws of physics. Energy can neither be created nor destroyed, but so I believe in the laws of physics, so you'll have to excuse me. There's another number of interest, and you can think of this as a reference number. And this number goes all the way back to the ancient Greeks, and it's 10 to the 50th. And what this number represents, it represents the largest number that would have any significance or any meaning. In other words, what the ancient Greeks are saying is that if you come across a number that's greater than that, then you can just discard it. It's a number that, if any number is greater than that, it's insignificant. It doesn't have a whole lot of meaning. And then this gets into the area of what I was recording this video for. There was another number that I've come across, and there's a bunch of these numbers. There are certain numbers out there that, like pi, for example, is a significant number. The logarithmic number, 2.71, whatever that is. There's various numbers that have certain significant meanings, and these are a few. And there's another one here that's of interest, and it's 10 to the 150th power. And what this number represents, rather interesting number to me, and I'll just let the author speak for himself. And by the way, I'm reading, just so you'll know, I don't want to be deceptive in any way, shape, or form, but this is the book Evolution Impossible. I don't know if you could see that on the screen or not. I hope the camera can pick that up. But there is a guy in here, and his name is William A. Dembski. Now, William A. Dembski is of the University of Chicago, a trained mathematician who authored a book called The Design Inference. And it says Dembski has shown mathematically that chance can be eliminated as a plausible explanation for a specific or a specified system. Now, what they're talking about in terms of a specified system would be like a living organism. And if you're going to go down that road and down that path, you've got to find the most simplified living organism that there exists on the planet. And one of the ones that's often studied is E. coli, or Escherichia coli, coming from the name of the scientist that discovered Professor Screech in 1885. Coli, of course, colon, so it lives in the human body. However, there's even a smaller living organism that lives in the human body. And let me turn down this mic ever so slightly. And it is called Mycoplasma genitalium. Mycoplasma genitalium, which lives in humans, now get this, has only 471 genes. That's pretty darn, that's the smallest of the small. So if you want to know what is the smallest living creature on the face of this planet, well, now you know. Mycoplasma genitalium, 471 genes that we know of today. It may not be the smallest, but it's the smallest one that's we're aware of, or scientists are aware of. But what the author of this book does, he takes it even one step further. Let's just go as far as we can. Let's give scientists every benefit of the doubt, and this is what he's saying. And let's not even talk about Mycoplasma genitalium or Escherichia coli. Let's talk about, let's let the author again speak for himself. He says, let's talk about amino acids. For example, consider the probability of a short, specifically coded protein molecule 100 amino acids in length. So he's taken it to a whole other level. He's going beyond the smallest living organism and saying, let's go to the nth degree. Let's just imagine you had 100 amino acids. And of course, those are building blocks of life. In length, arising from chance from its amino acid building blocks. And then he goes on to say, the probability of building a 100 amino acid chain with only peptide bonds is 10 to the 30th. So let's write that number. Seems a little familiar, right? This number right here, 10 to the 30th, which rather interestingly enough, coincides with the number of seconds since the Big Bang. I mean, if that isn't bizarre, think of that. So if you base that upon this professor, and I'll get his name here, William Dembski, and he is, what does they say about him? William Dembski, University of Chicago, trained mathematician who authored the design inference. And then he talks about his specified system when it exceeds the available probabilistic resources. So, and this author of this particular book takes that to the next level and talks about 100 amino acids. And the probability of 100 amino acids coming into existence is 10 to the 30th. But yet we only have 10 to the 30th seconds since the Big Bang. You understand? You understand what's going on here? There's just not enough time for even 100 amino acids. And I could go even further than that. I can give you a number, and I'll leave it at this. And this is a number by a group of Russian scientists not too long ago, within the last, I think, year and a half. Now, what would that number represent? Ooh, 10 to the 150 thousandths. What does this number represent? This is Electronic Wizard signing off.